Welcome to today's session. In our previous session, we have discussed OOPS concepts in Python. What is class, what is object, and what is constructor, what is self parameter. So, like that, we have discussed various basic concepts in OOPS. In today's session, we are going to discuss very important OOPS, four pillars of OOPS, that is abstraction, encapsulation, inheritance, and polymorphism. These four we are going to discuss in this session. Okay, let us start. Let me share my screen. So in our previous session I have ended here abstraction, encapsulation, inheritance, and polymorphism. Okay, these are very important. Okay, even if and very easy also, it is not that difficult. What you have to do before you get into real world scenarios, for each and every pillar, I would say these are the four pillars of OOPS. Okay, so for each and every pillar, each and every one, you take one practice question and you try to solve it. Then also it becomes more easy. Now, while remembering, if in interview you are asked what are the four pillars of Python, then abstraction, encapsulation, inheritance, polymorphism, you can give this answer like A, next E, next I, next P. These four are in alphabetical order, right? A, E, I, P. This is the sequence you can explain, because this in alphabetical order, easy to remember. However, while learning, let us not take this route. Let us follow first encapsulation. This route is preferred. Uh, why and all you will understand after you complete your learning everything. But for now, this order is preferred. Now, what is encapsulation? Okay, so the name itself suggests capsule. Capsule means what? You are trying to bind it, right? So the definition is the the feature of Python, or the ability of Python, or I would say not the ability. So the ability to bind objects and methods. Sorry. Okay, let me repeat. The ability to bind attributes and methods. Okay, that is called as encapsulation. For full definition, you can refer Google ChatGPT. However, try to understand the concept, the ability to bind attributes and methods, and thereby providing the access. That is called as encapsulation. Means, now let me quickly show you the example which is already there handy with me. See here, this is the best example for encapsulation. Um, Here, this balance, amount, these two are attributes, and this deposit, get balance are the methods. This is the constructor. So here what we are doing, this is all related to bank account, like how much you deposited and what is your current balance. So these all related, right? And the programmer, whoever is writing the program, he is binding all that thing in a single class. and you just have to create a class, create a object BA bank account equal to, okay, and you can call those methods, okay, BA dot whatever. For example, you want to print the balance. First of all, here one parameter it is expecting, so you have to give the bank balance, I mean pass 20,000. Okay, print b dot balance. Okay, and then you have to call BA. Then you have to call these methods deposit, and while calling also you are deposited 10,000. Okay, then you call the you what is the balance, like bank balance is 20,000, you have deposited 10,000, then what is the final balance? Okay, and you just this one mention in the print statement. Not required, or like you can write like this, the balance is, no need of formatted string here because okay, okay, fine. Bank account as allow me sometime. Object has no attribute underscore underscore balance. Okay, balance object has bank account object has no attribute. Okay, let me not why this. Okay, initially 20,000 is the balance, and after final balance, after depositing 10,000, after I mean why the initial double underscore did not work, we can see later. Of the final balance after depositing 10,000, the final balance has become 30,000. So I mean you will get the question, what is the difference? Previously also object is there, and this is the same way we were writing the program. Okay, so what is the object? Object here, BA is the object. What is that object? Is, I mean it can have the attributes and methods, right? These are the attributes, balance, amount, these are the attributes, and this is the method, and this is the constructor, and that is what is the object. But the programmer or the developer, whoever is writing this kind of code, that feature is called as encapsulation. Okay, he is um, binding the those particular I mean attributes and functions or methods in like in a single class, or depends on the requirement in the class, and thereby allowing the access. Okay, so now if you create a separate class, let us say bank account, next some other class, and that person cannot access this bank account, right? So that is the encapsulation. So the thing is, it is the same thing which we have written previously. However, we have unconsciously or without knowing this thing, we have written the program. But nonetheless, the object is an instance of class. Okay, object is an instance of class, and it also has the attributes and related attributes and methods. However, while the programmer is trying to bind these attributes and methods, okay, that is called as encapsulation. Okay, um, in your real time, when you are solving the real world scenarios, these four things will make huge difference. How these four things will make huge difference, and also you will gradually see, and with this example itself it is very clear, right? Like these things are all belong to bank account, balance, deposit, okay, and whatever loan. These things are all belong to bank account, so you cannot unbind these things like in a separate way, different places and all. You have to bind these things in a single class. So that is encapsulation. This is very simple, not much explanation is needed. But for other things, for abstraction, inheritance, polymorphism, a lot of explanation is required, and careful understanding of definitions and writing the programs is required. Okay. Yeah, if you get any doubt, please do not hesitate and please kindly pause me, because these are very important. Now, abstraction. Abstraction means hiding the implementation details. I mean, remember these one-liners, it will make a huge difference. I mean, in the sense, why whatever rest of the definition, for example, not only in interviews and while you are learning, while you are applying, in all these places, these one-liners will help a lot. So, abstraction means hiding the implementation details. But definition is not complete. If you remember this one, the second portion of definition is easy. Hiding the implementation of details and exposing only exposing only necessary details. This is called as abstraction. Okay, I will explain two simple analogies with which you can easily understand. Okay, number one example is ATM example. Number one, ATM. Suppose you go to ATM, what you will do? You will, I mean, insert your card, and you will also enter the PIN, and then once the PIN is entered, what will happen? Your how much amount you want to withdraw, right? You want to withdraw some 10,000, 20,000. You enter that amount, and that amount is deducted from
Come
your
out.
bank account. Yeah, amount is deducted from your bank account, and you will collect the cash. These are all the things that are done. Now, now, but that is all not what has happened. The ATM, the system, it will verify your bank account, and that PIN is correctly matching or not. And I mean, how whether this person has that much amount in his bank balance or not. So that the system will hit the database, bank database behind this and all, right? So this and all are not required to expose when you write the program. Okay. uh, Only that portion which the user is interacting with that system, that needs to be, I mean, exposed, and the remaining implementation details are all hidden. So this is one example of abstraction, hiding the implementation details. What that means? it is verifying the account, hitting the database, verifying the account, verifying the PIN, and verifying balance, then returning again to the user. This uh, this kind of thing is called as abstraction, and only exposing what is necessary. Now, let me give another example. Second example is car. For example, when you are driving a car, what you will do? You just have to know where is the steering, where is the, brake, where is the accelerator, and where is the brakes or gear. So these things are sufficient, but you don't need like how the engine is working and how the engine is moving the car, like what will happen after you, hit the brake, and how the wheels are stopped suddenly. Those are details are not necessary. Okay. So these are the two simple examples to remember. So hiding the implementation details and exposing only what is necessary. This is called as abstraction. So I just gave two real world scenarios. Now let us understand through some program. Uh, 1 minute. Ah, okay. Yes. Here see ninth one. Ninth one is one scenario. What it is saying? Create abstract class with method make payment, implement in credit card and UPI. Okay. Uh, Create an abstract class. Okay. No issue. So let me now, this is day 7, day underscore 7 dot py. I think I have to share day 6 dot py. I will share it today. I forgot. Now, um, this one is okay. Create abstract class payment with method make underscore payment. Okay. Here, few more important details are necessary. That is, from ABC import ABC and uh, abstract method. So you will wonder where these things are coming into picture. So this is the Python built-in libraries. Okay, built-in libraries. You don't need to. These are not third party at all. Okay, sometimes, for example, when you are trying to integrate certain things, for example, your program needs to integrate with Razorpay. Okay, then I mean, then you have to, whatever, not Razorpay, you can take some other things like Oracle. Okay, Oracle database, Snowflake database, then you have to import those libraries, right? But nonetheless, this one is not the third party library, it is Python's built-in library, this ABC. Now what this ABC is? ABC stands for abstract base class. Okay, that is what is abstract base class. So from this abstract base class, which is built in Python library, you have to import one abstract base class and abstract method. So this is standard. You don't need to, you can just by heart it now and, right now and then, now and there. So if you want to implement abstraction, you have to write this one, write this line. Now once you are done, so it is asking if you remember the question. actually not, you could not copy. Let me try to copy here. Okay, so create abstract class payment with method make payment and implement that in credit card and UPI. Okay, but I mean I gave the abstraction definition and I am writing the program. However, there are much more things which are which you need to know. Few things. Number one, this one I have explained. You have to import this one. And second thing, for abstract class, you there is no instance creation. Okay, you cannot create an instance for the abstract class. Let me explain. Okay, class payment, that is what is asked. Create abstract class payment. How you will create? Class pays payment and in brackets you mention ABC. Okay, I will write the program, but create abstract class payment. How will you create? Like this you have to create. First you have to import ABC and abstract method from ABC Python built-in library, and then this one you have to write this in the brackets. So in brackets, whenever this ABC abstract base class is there, those classes are called as abstract classes. And for those classes, you cannot implement the, I mean, if you implement what you will pass here, right? So you cannot instantiate for those abstract classes, or I mean, not you cannot, they cannot be instantiated. That is like, let me, what do we say? Degrees of, okay, whatever. So abstract base classes cannot be instantiated. Let me write down here. Second point, they can not be instantiated. So we cannot write like this. Then how will you implement this one? Okay, by implement in credit card and UPI. This again will come in inheritance. Credit card of payment. Okay, now this one you can instantiate. Okay, C equal to CC equal to credit card. Okay, you can instantiate. I mean, uh, here I did not write pass. I am going little carefully and slowly and try to pay as much as attention as possible. Implement in credit card and implement in UPI. So let me take another class UPI of payment. Okay, now you will get the doubt. This payment class, this ABC you have written here. So that itself is called as inheritance. Okay, which is the another OOP principle. Okay, which will is the next one, third one. So it will come. Okay, please wait.
Sir,
Now, mm,
totally abstraction means it will only show the necessary details. What we want.
uh, you are giving the second part of the definition, which is less weightage. Abstraction, I mean, like means hiding the implementation details.
Okay. Hiding the
You can,
important details and giving the necessary details. Like this.
let us see this one. Abstraction, abstract meaning. Okay, I don't know. but I mean I'm not that good at English. Process of hiding. So it is in computers, not in computer science. Even in normal English, abstraction means it is a hiding. So that is why these one-liners are more important. The remaining, so yeah. So the second time when you told whatever you told is correct. So we are hiding the implementation details and exposing only necessary details.
Okay,
Now, mm, now this payment, how it is happening, that is that we have written an abstract class.
sir,
And
when we put ABC in programming, it will become under abstraction method.
yes, abstraction class. Abstract method I am about to write, I will explain.
Okay, sir.
If you put ABC, that will call as abstract class. And
Okay, sir.
the way you are putting ABC here, that is called as inheritance, which will come up in the next OOPS concept, OOPS principle. Next, one of the pillars of OOPS, inheritance. So you are inheriting that thing here in this class. Like for example, a son inherits the father's property. Okay, and also uh, what do we say? We inherit our grandsisters or ancestors, right? Certain
Yeah.
things. What do we
Properties,
say?
like properties.
Not property. There are other things also we inherit. Okay, their features are not features. Some things not required. Yeah, one example is sufficient. Um, so therefore, that is called as inheritance. This the way we are writing ABC in the brackets, because this is also class. See, credit card is also class, payment is also class. Why are we writing payment in these brackets? That is called as inheritance. So the inheritance we are inheriting from this one, and this is called as child class, and this is called as parent class. So that much is sufficient for now. Let us first complete the abstraction, then we will go to inheritance. But nonetheless, sometimes what will happen, you cannot isolately explain one concept actually, because when you are writing programs, you have to combine them and write sometimes all, I mean, in the four pillars, either two or three, like all you have to combine and write. So so that much is sufficient for inheritance. More details will come later. Now, okay, I have to explain. Okay, we will see. Um, correct. Here, that is also they cannot be instantiated. And another important thing I have to explain here, that is what is decorator. Okay, this one also right after abstraction I will explain what is decorator. For now, For now, let us complete this one. Mm. Now, diff abstract method. Okay. Now, okay, what it is asking, with method make payment. Sorry. Uh, with method make payment. Mm, somewhere I am gone. Let me. Okay. With method make payment. Let me complete this one and then got it. Okay. Hmm. Okay, here let me print um, and let me self through credit card you have done some amount. Okay, through UPI you have um, deducted some amount, let us say. Okay, then uh, and here now let me pass through credit card 10,000 and through UPI will do uh, 20,000. Okay. Not here. I have created the objects and I am calling cc dot make payment UPI dot make payment. So here I am passing 10,000. Here I am passing 20,000. Okay. UPI underscore UPI1 because that UPI is already class name is there. So UPI1. Now, um, yeah. Now, but this method, okay, here we will need some explanation. So the program is not over because you have just because you have inherited doesn't mean that I mean this class became abstract class. But where are you using this apps? Where are you hiding this method, right? So you have to decorate it with like this at the rate. Okay. Even I mean, let me see. Okay, now I think print from credit card the amount deducted is AMT. Next, from UPI, the amount deducted is AMT. Okay, formatted string F. Let me run this. If we get any error, we will see. And then I will explain. Okay, from UPI, the amount deducted is from credit card, the amount deducted is 10,000, and from UPI, the amount deducted is 20,000. Okay, so uh, now here few things we are almost understood the concept of abstraction. Here, this from ABC was inherited here and in the payment class. And this payment class we have inherited. That means these two are the child classes which inherited from payment. Okay. And the payment is done. Successfully, the payment is done. But sir, I mean, where is this? What is this abstract method suddenly? Okay, this abstract method means this app we are, I mean, you have to, this is the syntax. So now you may get the doubt. I mean, what is this abstract method? Okay, I mean, we have I mean, this ABC we have written here, and this has become abstract class. And this payment we have inherited in these two classes. So implementation, I mean, this one is exposed, and whatever, I mean, implementation like background we are doing, like it is hitting the database. Okay, all these things we have hidden. Okay, here we have not, I mean, that too much real world scenario we can implement, right? We have not integrate all the things now, integrating database, integrating the entire thing you cannot do. I mean, it is not, so it is more close real world scenario, but it is not real time project. That is a project. Now, now what I am trying to explain here, this abstract method, just like you have inherited this ABC and made this one as abstract class, we similar way you have to inherit this abstract method, not inherit, you have to decorate this make payment with this this abstract method. Okay, so this abstract method, if you write like this at the rate abstract class, okay, this is the syntax, just memorize it, then we will come to decorator in a separate program, which is very important and required to know. It is a very important interview question, because many people get confused at that place. And first question, if you go to interview for Python, they will ask what is decorator, can you give me example, and write a program. This is the first question, will mostly it will come in interview. Because okay, for now what you have to remember, because inheritance also whatever is necessary for this program I told, in the same way for this one also, how much is necessary, that much you memorize and understand the concept. Just like we have used ABC here and made this an abstract class, similar way we have to write the syntax at the rate abstract method to make this as abstract method. Okay, the way we are writing is itself called as decorator. Okay, we are decorating this method. If you write here, that this also becomes a decorator. And what is the decorator, we will see. But for now, just like how we have written that class here and made this an abstract class, similar way you write this abstract method here and make this entire function abstract, entire method as abstract method. So these things cannot be called. Okay, you cannot instantiate, or you cannot call these abstract methods, because they are hidden. These implementation details are hidden. Okay, that is what is abstraction. Okay, so we are only displaying the end user, like whatever is necessary, that much only we are displaying, and whatever is implementing in the background, that thing we are hiding it by these two things, by mentioning ABC here, and by whatever method is there, you are like decorating it with abstract method. You are completely hiding this implementation and exposing only this much. Okay, are you clear with abstraction? Okay, are you clear?
Yes, sir.
Now, what is decorator? So you need lot of practice. Okay, what is decorator? Decorator is a function, okay, which takes another function as argument and modifies or enhances it without changing the code. Okay, I will explain. No need to get confused. Let me maybe add another. Okay, decorator, it's a function which takes another function as argument. Okay, and modifies or enhances it without changing the code. This is the first line of first part of definition. This is the second part of definition. So and I would like to double check if recording is going on. Yeah. Okay. So it's a function which takes another function as argument and modifies. Okay. Um, mm, Now this one is little difficult, little uh, difficult at this level to understand, but this is a very important question in interview. For example, def say hello. Okay, print hello. Now this function is a normal function. Okay, this is a very normal function. Now what I want to do, uh, I want to see, now I want to write a decorator. Okay, let me write a decorator. Def my decorator, and we have to pass something, right? So see, decorator, I am writing a decorator. It's a function. This is a function. It takes another function as argument. Okay, I am writing. I mean, I will pass this say hello to here. Please wait. But for now, I am passing this function as argument. Okay. Now, uh, it modifies and enhances it without changing the code. That means this say hello function, it will modify the behavior. I would say enhances the behavior. Okay, without changing the code. Now, uh, it is something like, for example, somebody gave you some package. Okay, some gift package. Take it, Bhuvan. This is a gift for you. Something like that. They have given some gift package. Now you are changing it. So that means, I mean, the and you want to, I mean, put it on some wrapper. This is also like without wrapper. That is one way of understanding. So let me explain. Print before hello, print not here. Here I have to call this function func, then print after hello. Okay. Now this function, whatever you are passing here, that only you are calling here. Okay. This function is a say hello function. How it will happen? By decorating it. By you just have to decorate it. I will explain. Okay. Somewhere I am wrong. Acha, not required. We have already written this one. So I am executing this one. No, I have not returned here. I have not returned. So you watch this video again, practice. That is how you will gain the experience and clear the interview. Uh, uh, um, okay. Hmm. So the thing is, now let me execute, and if you see the output, then I will before hello, hello, after hello. So now if you carefully examine, you are calling this say hello function only. Okay, you are calling this say hello function only, and it should print hello only, but it is not printing hello. It is printing before hello, hello, after hello. Okay, so that is called as decorator. The syntax I will explain, okay, but you just understand the underlying concept. So this is the decorator. This is the decorator. Now, what this decorator is doing, it is, I mean, it is a function. It takes another function as argument, modifies or enhances the behavior without changing the code. It is not changing this at all, hello, but it is modifying the behavior. So whenever you are calling this say hello function, instead of printing hello, it is printing before hello, hello, after hello. That means the it modified that behavior. So that is the use of decorator. So you have to practice it, and but for now, how this will work at the rate my decorator, how it will work, that part I will explain. This one is same as, okay, these two lines at the rate my decorator and say hello, these two lines are same as this one. Okay. Hmm. Let me again execute. um, yeah, okay, that is I am clearing this one and I am executing this one. Okay, before hello, hello, after hello. So these two lines are same as these two lines. Means this is what is the again the same definition, right? Decorator is a function. It is taking another function as argument and modifies or enhances, and again this returning. It is has returned this wrapper to it, and that is printing. So I mean, whichever is easy for you to memorize and practice, you can do either this line or this line. Whichever is feasible, you can do. What else I have to cover here? Okay, so this is the decorator. Now, if you remember our previous abstraction, wherein we did not write like this, okay? We have written like this. So we have just used this at the rate abstract method I mean, we have decorated it with @abstract by writing @abstract. But nonetheless, unlike here, um, but this one is a pre-built here. Here, this one we are externally we have written this my decorator. But here for abstract method, this is an inbuilt method. That is the only difference. Okay, meaning this decorator, whatever I have explained, it is this much is sufficient for interviews and understanding and all. And you can take 2 or 3 examples and practice for you to absorb this concept. However, in your real-time implementation, which is done in abstraction, you you don't need to separately write the decorator. Okay, this inbuilt method is there, abstract method, and you just have to wherever you need, you just write this decorator. Okay, for example, this @decorator I have written my decorator, which I have written here. And let us say there is another function def underscore say by. Okay, print by. Why this to create terminal? Now I am not creating terminal. Okay, now say by. This one is not decorator. Okay, let me execute this one. Before hello, hello, after hello, by. Okay, this is not decorator. But now if we put this one, then again it becomes decorator. Let me now again execute. Okay, I mean that means before saying bye also you are saying hello hello. Okay, so already you are leaving, but you are saying again hello hello. So just I am saying humorously, but hope you understand the concept. So whenever you are defining your own decorators, you have to define it one time like this, and wherever you want to use the decorator, whichever method you want to decorate it, you just write it like this. Write it like this. That is sufficient. If you don't write like this, that is again normal function. If you write like this, then it is a decorator. This I mean, you are decorating this function by and changing that behavior. That is the meaning. And without changing the code, you are not changing code here. You are not changing any code here. Okay, this is decorator. You can have this recorded video, but nonetheless, for implementation purposes, if any method is already inbuilt methods are there, you can you don't need to specifically, I mean, write the decorator and all. Like this one, you don't need to separately write another function like this. Okay, you can just decorate it in case of abstraction. But if it is not, I mean, anything is not there, custom code that you have to write it and you have to decorate those methods. Okay, so this is the decorator, which is a very important interview question. And write this program and practice some other programs. Okay, don't think um, whether I can be able to do. Okay, don't have that kind of assumption. So abstraction is completed. Now inheritance. So so I missed the super, that is comes in inheritance only. Okay, now inheritance, which is also very important. So inheritance, various, there are 5 types of inheritance. Okay, um single inheritance, multiple inheritance, multi-level inheritance. Next, fourth one is hierarchical inheritance and hybrid inheritance. Okay, so these are also very simple. You just have to have some cool head and study these things. These are not complex at all. Single inheritance means there is only one base class and one child class. That is called as single inheritance. Multiple inheritance means there are multiple base classes and single derived child class. This is multiple inheritance. Let me put the line here. Okay. Next thing is multi-level. Multi-level inheritance means this one, like B has inherited from B, from A, C has inherited from B. That is called as multi-level inheritance. Then enough here. Now hierarchical inheritance, or we will do the numbering 2, 1, 2, 3. Now I am explaining 4 here. For hierarchical inheritance means from A, 2 are there, exactly ulta of second one. You can, if you compare this one and this one, okay, there is exactly ulta. Compare these two. Like multiple inheritance means from multiple classes, one derived class has, we have has come. But hierarchical inheritance means from single base class, multiple child classes are derived. That is called as hierarchical inheritance. Okay. Next, hybrid inheritance. You just combine it. It is a diamond will come. Fifth one is hybrid inheritance. Hybrid inheritance A, B, C, D. This is called as hybrid inheritance. Okay. So these, as I mentioned, these are just names, nothing to worry and all. If you see, therefore, theory and practice both balanced way you do, then it becomes easy for you. Now, quickly, let us write one program. Let us see, first of all, what is the program? Inheritance. Huh. Create a base class and derived class car and bike with specific attributes. Okay, base class vehicle. Okay, let me copy this one. So inheritance, you only explained the definition, like child inherits the father's property, son inherits the father's property. Same thing, like whatever the attributes and methods that are present in the parent class, the child class attribute can inherit those things. Now, What is the question? Create a base class vehicle. Let me create the vehicle. Okay. Now, and derived classes car and bike. So from this vehicle, car and bike with okay. Then what it is saying, create a base class and with specific attributes. I think this is basic level. I have put intermediate. Okay, no problem. Okay, no issue. Specific attributes. Um, okay, we will do 1 minute. Immediately you cannot write the real world scenario here completely, but you can write something very close, but not self, comma, specific attributes. What vehicle will have engine or engine model something. Okay, and self dot engine. Okay, let me do one thing. Engine. Then car will have four wheels. Okay, def. Um, Start. Okay, let us do one thing. Def start print vehicle started. So and also observe the way how I am writing the program. So immediately, probably before the session, before the course, in a one-to-one session, I have explained like 8 levels of some 8 levels of mastering the programming or to become a good coder. Okay, we are somewhere in the middle right now. Car started. Def start print bike started. Okay, this inheritance, there are many concepts like there is a method overriding concept is also there. After this one, I will explain that one. And super method also I have to explain. But for now, with specific attributes. Hmm. Now, and let me write a stop method also. So. Hmm. So first this one will be called and then that start. Hmm. Got it. Self. Okay. So um, first of all, when you got this question, first you have to understand this is falling under which category. Can you tell me, Bhuvan? 1, 2, I have explained this 1, 2, 3, 4, 5. Diagrams are also there. Now,
Okay.
this question, create a base class and derived classes car and bike with specific attributes. So this one is falling under which type of inheritance?
Can you show me the question once?
Hmm.
Okay.
Hmm.
Sir, I think it's hierarchy.
Correct, correct, good. So it is comes under hierarchical inheritance. So this car and bike can inherit the vehicles, attributes, and methods. But here it is mentioned only attributes. So we have overwritten the program. Let me quickly, I mean, uh, stop here and put pass. Because see, at this point, these are not, this is, we are trying to mock up the real world scenario, but nonetheless, this is not real world project. So you cannot be able to, for now, for understanding basis and logic basis and like this, we are writing, okay? C equal to car, okay? That is sufficient. And then, but while okay, let me do this one. Okay. Of um, what is the engine? Maybe we will put. I mean, I don't know so many names. Just we will put Maruti. Okay. Then we will also another object B equal to bike C dot model of what is that one? Unicorn. So actually, I think. Whatever, even if output comes also, output, okay, let me see. Yeah, we did not print C dot, mm, okay. Why I'm doing, getting confused. Mm, INIT is the, then we have to use INIT only, and then we have to, um, write. So, let us print in a single go. C dot engine, capital E or small e, small e, comma B dot engine. But these are not, these are, okay, Maruti Unicorn. I mean, so what has happened if you carefully for this one, or let me remember this thing, then it becomes easy. And sometimes you try to understand by negation, then also your understandings will become fast. What is that negation? Ideally, what this has to do? Okay, tell me what ideally we have to do. We have to write def underscore underscore init, right? And in brackets self comma engine. Okay, then self dot engine equal to engine. This is what we have to ideally write for this to work. Okay, let me now, I mean, comment this one. But anyway, let me not, I mean, the point which I am trying to highlight. Ideally, we have for this one, you are initializing one, creating one object of car class, and you are passing this Maruti. Okay, for this one, if has to work, ideally it should be like this. Okay, then only, because this is a constructor, and this will accept this self is the current object, current instance, and this engine is the Maruti. Then this will work. But now what we have done, we did not write this one at all. Okay, we did not write this one at all. We just for all these car, bike, truck, bus, so many are there, let us say. For all these things, we have written one parent class, and we have declared those attributes. Okay, there are some common attributes for all these vehicles, just like there are some common attributes for all the employees in the organization, and there are some common attributes for all the students in a class, right? For all these things, you are just writing one parent class, and you are inheriting this parent class in these child classes. Okay, so there is a, I mean, this is inheritance is the OOPS feature. Okay, one of the pillars of OOPS. So as you go more and more to real world scenarios, then you will see this application more precisely. For now, I mean, through these examples, through simple programs, you should be able to absorb the concepts. Now, I have not written the constructor in the car class, but still my program has worked and it has written that engine. So that means what has happened? That means it has written. That means what has happened? This particular object, child class object, has inherited the parent class attribute. This engine is the parent class attribute, vehicle, not this class attribute. But still this worked because we have written this vehicle here, and immediately this has become the child class and this has become the parent class. And when you initialize this one by passing this one, this has inherited this attribute, and c dot engine, that object, that child class object, has that attribute of engine. Okay, similarly bike class, ideally for this one to work, bike unicorn to work, you have to write a constructor here, and you have to initialize this parameter, whatever you are passing, you have to initialize here in the constructor. But without doing this, you have written just pass. Without doing this, this got worked, and this has returned unicorn. That means this what has happened behind, at the moment you have written this vehicle here, this became child class and this became parent class, and therefore this child class object has inherited the parent class attribute. Okay, this engine is belongs to parent class. You did not create anything like this at all. There is no mentioning of this line, but still this worked because that is the meaning of inheritance. So inheritance is a way by which the child class object can inherit the can inherit the parent class attributes and methods. And there are 5 types of inheritance: single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So all are simple only. Like for example, if you are taking the third one, okay, then you just have to do like this: class, uh, what will have, bike will have, car, bike, all will have brakes, right? Brakes. Then you take car, write car here, and whatever you want to write, you can write it here. Okay, you want to write car brakes are working. Okay, right away you can write the print statement. Now what I will do, I will um we will see later. This one is brk equal to brakes. Uh, Let us write in one function. Okay, def because this is some function is happening, right? Some things are, brakes are working or not, you are checking car brakes are working or not. So def um, what we will mention, um, function or um, car run service or whatever. Okay, while servicing and all you are checking, let us say. Okay, now brk dot service, okay, dot service. So immediately it should return car brakes are working. Okay, car brakes are working. So the point now what I am trying to highlight, this one is called as multi-level inheritance. Third one, this is the vehicle, this is the car, and this is the brakes. Okay, there is here there is ideally same, you take the opposite scenario. Ideally this one to work, what should happen? Okay, this uh, you have to write like this also, right? In the sense, for car also you have to write something like I have brakes. For bike also, yes, I have brakes. Otherwise, the how this will know, right? I mean, don't think immediately how car will have the mouth to speak. So don't think like that. The point is, from car did not communicate like I have brakes, bike did not communicate I have brakes. But nonetheless, when we are this service, when you are calling, immediately like it has written car brakes are working. That is because you have inherited that car class here. So immediately brakes, child class of car will know. So vehicle is inherited written here, and car became the child class, and brakes has written here. So this brakes is the grandchild of vehicle. Okay, brakes is the grandchild of vehicle. So that is the way it will work. And you cannot like this brakes and engine both are you cannot write like this here. Again, brakes off, it will throw error. Okay, where this one has this kind of thing, it did not have this one and this one. It has taken from this parent class, and you cannot pass something like this how you have passed. Okay, anyway, so this little close to real world scenarios which you are writing, but when you really come to the real world projects and all, this whoops has lot of application, and without you whoops object oriented, uh, so before what is there, it is just the procedural oriented language. Procedure oriented means some bunch of code you are wrapping it in some like this. All the code, like I mean this is piece uh, piece one, okay, and there also previously also before object oriented programming has evolved, there is a blocking, I mean blocks of code. I would say not piece, I would say block. This is one block. There is this kind of thing is there, but nonetheless, then again there is lot of drawbacks in the sense you cannot fully able to solve the real world scenarios. Okay, so therefore this oops will be very, I mean popular, became very popular. Okay, now inheritance, single, multiple, multi-level, hierarchical, hybrid. I have just written two examples. One is for hierarchical and another is multi-level. Other things are also easy only. Single, these are also same only. Now, actually, there is a now quickly, yeah, this is very important. Now, um, there is another thing concept called method overriding. Okay, in oops, what is method overriding? Right? For example, now let me write this one def start stop. Okay, start print vehicle started def something is wrong. Yeah, def start print car started. Okay, stop. I'm not explaining. Let's not over complicate these simple things. Print bike started. So now, um, okay. Now, for your explanation perspective, let me comment this one and this one. Okay. And then let me, for the car object, let me call this start. Okay. C dot start. Takes, okay. I have to give self here. Okay. You see this error. Vehicle start takes zero position argument, but one was given. What one was given? This C itself is passed as the first argument. Okay, so you have to mention first parameter. So you have to mention self here. So now, okay, vehicle started. So because of the inheritance property, it worked. Okay, because of the inheritance property, even though you are calling the start method from child class object, it worked. However, now if I write this one, now I am uncommenting this one. Now Can you tell what will happen? What will be the output? Let me give some enter here. This is the previous output. I have uncommented these 3 lines, these 2 lines. Now, Bhuvan, can you tell what is the output?
Thinking, sir.
Hmm.
Thinking, sir.
Yeah, no problem. I mean, actually, we don't have much time. So, whatever you can tell quickly. Actually, the error will come because I have to give self here. Yeah, no, tell me.
Sir, I think it will only print car brakes are working and Maruti Unicorn because it is a car.
Okay,
You
no,
have
I have written this one, car c dot start. This start method I am calling. So what I am, oh, but anyway, okay, you are saying vehicle started will not print.
yeah.
What about car started?
It will print, sir, because it is not on comments like
Okay, got it. So answer is correct, but I want to help you to understand the underlying concept.
okay.
So previously, this start from car object, this start it worked. Now, why this vehicle started? Now, why it is not coming? Rather, it will print car started, because this method we have overridden with the new functionality or new whatever new functionality. So that is called as method overriding. Okay, method overriding exact definition. Uh, in the sense, see, another again you might get some question. Uh, Sir, you are telling method overriding, but even without knowing that method overriding, if I c dot start, if I write, it will call like this. It will print like this only. As per the OOPS phenomena, I mean OOPS concepts, it will print like this only. But the concept of method overriding is something you are doing explicitly. Method overriding means, okay, the child class will have its own implementation of parent class method which it derived. So you are explicitly, no, I want a different functionality, its own, I want a different implementation for this parent class method. Like that, you are explicitly doing it. That is called as method overriding. So, okay, it is the, I mean, even without method overriding, generally the OOPS will based on the precedence. Let me you explain like this. It will become easy for you. In our previous day, this attribute resolution, okay, this one, okay, based on this attribute resolution or precedence, what OOPS will do? First, first the object or instance. Next thing, it will go to class. Next, parent class. Okay, if this class is missing, then it will go to parent class. Now, here, if this is missing, like this one is missing, it will print that only. It will print vehicle started only. See, vehicle started only. So this is the oops precedence. It will work like this. It means first object, next class, next parent class, next grandparent class. Like that only it will work. But method overriding is something you are explicitly trying to change the functionality. Okay, different see, vehicle started did not print, car started. So this is called as method overriding. The child class will have its own implementation of parent class method which is derived. Okay, I mean, so the previous one precedence is something which is implicit, which oops, as per the oops it generally does. However, the method overriding is something that the programmer or the developer he is explicitly writing in the child, I mean the child class its own implementation or its own uh, functionality to the of that particular method which it is deriving. So this is method overriding, which is very important. Now, uh, okay, now we are already running out of time. Let me quickly see what all pending. Polymorphism and super. Okay, now quickly super. There is one thing called uh, super method. What is super method? Okay, it is um, exact definition is I mean parent class method you can call from the child class. Okay, exact is okay. It is used to access the uh, next level hierarchy, next immediate level, not like not like this one it will not happen, means not like multi-level inheritance. From C you cannot write super and access A, that is not possible. Okay, from C you cannot access A using super. From C you can access B's methods, and from B you can access A's method using super. Okay, uh, okay, it is used to exact definition next class in the inheritance hierarchy. Okay, quickly we will see this one. For example, now I want to access what I want to access from car here, but here some space is there. Okay, no issue. So um, okay. Mm. Okay. Okay. Say super dot. I mean parent. So next hierarchy constructor or next in the inheritance like base. I mean class one, child class, sub child, like that in the inheritance. What is the next level methods and constructor both you can access. Okay, that point also I want to mention. So use it to access the next class in the inheritance hierarchy, both methods and constructor. So now I want to quickly access this constructor. So I can do like this, and uh, let us say now um, car. Actually, I don't know much car names, but okay. And you can now um, print self dot okay, it will not understand self. So let us write here. Uh, okay. Now see here what I am trying to do. I just added 2 lines of code from the previous program. What these 2 lines I am doing? Using this super method, I am trying to access the this next level, okay, this of method, next level constructor. This constructor I am accessing and passing this car, okay. Then I will get immediately self dot engine. Whether I have to add self here or not, let us see. Let me run. See, car2 printed. Car after car started, car2 was printed. So this already car object is passed here in the self. So you don't need to mention again self here. Not required. Already car object is passed and you are trying to access the next level or next level or class in the inheritance, whether it can be constructor or it can be um, normal method. You can access normal method also. Start. Okay, it will print car vehicle started. Let me run. See, car2 vehicle started. So this is the super method. Use it to access the next class in the inheritance hierarchy, both methods and constructor, and attributes also, because inside the constructor you are only initializing those attributes. Okay, this is the super method. And finally, polymorphism. Polymorphism means the name itself suggests poly means many, many. Okay, morph means forms. Okay, many forms. So the concept is simple and it is which we already know, but nonetheless, see the same thing. This start. Let me now this one. This itself is called as polymorphism. Okay. However, same thing means the whoops by default has that feature. Each class can have its object and each class can have the same method. You can write the same method name. There is nothing wrong in that one. However, but when you are explicitly trying to do, okay, creating many forms of the same thing, start and all. So that is called as polymorphism. That therefore these two are encapsulation and polymorphism. These two you can you don't need to much work on these things, practice these things. Just one example if you practice, that is sufficient, and remember the memorize the definition. But these two, abstraction and inheritance, these two requires more practice. Okay, and this inside inheritance there is also another concept. In the abstraction there is another concept, that is decorators, which also I explained, and in the inheritance there is method overriding. Okay, that is also explained. Okay, apart from method overriding there is also another thing, that is operator overloading, which we will see in the next session. Now to conclude, today we have discussed these four pillars of OOPS. encapsulation, abstraction, inheritance, and polymorphism. Wherein encapsulation and polymorphism, you just try to by heart the definition, and one program if you practice, that is sufficient. So it is the ability of Python to bind the OOPS ability to our programmer's ability. OOPS will an object, the class, you have to combine both attributes and methods only. But nonetheless, for your specific program, which I have explained using the bank account, for a bank account, there are amount, balance, and deposit and loans, whatever, FDs, whatever. So all these things you are binding into single class. That that thing is called as encapsulation. And polymorphism means the same method you are trying to write in multiple classes by creating multiple forms. Okay, many forms. That is called as polymorphism. Poly means many, morph means forms. So like that, these two, just by the English terminology only, you will be able to understand. Not much explicit practice. Little practice is required, but not too much practice. But these two, abstraction, inheritance, you would need to practice programs, to also understand the concepts thoroughly, to execute, get the fix the errors, and those so on. So that's all for today.